So to continue with Chapter 11, we're now on to 11.2, which is about stream and river deposits. Before we get started with that, we should refer back to the essential question that we are using to frame all of our conversations around Chapter 11 in this unit. That question is, once again, how can we encourage those around us to be more responsible water users and protect others from pollution? So remember that we're using this question to kind of guide and frame our investigation of water. And we should be doing this so that we can understand, research, and propose a solution to a specific water problem that we will later identify in this unit. Chapter 11 talks specifically about streams and rivers and how they move sediment. So sediment is what we're referring to with this material, right? Is essentially just dirt, rocks, and any other material that gets moved by the river. Deposition is essentially a fancy word for the stuff, the sediment, the material that gets dropped or settled, or deposited, right? It gets deposited somewhere, meaning it gets carried by the river and then gets dropped off somewhere else. So this can happen in water where water will slow down. Generally, water will slow down because one body of water merges with another. So if you have a fast-moving river that then enters a pond or a lake, what you're going to have there is the water that's in the lake that is essentially not moving, and it's going to meet with the water from the river. When that happens, the fast-moving river water is going to slow down immediately. As it slows down, it's going to essentially drop any of the dirt or rocks or material that it was carrying with it, right? As it kind of hits the wall of non-moving lake water or ocean water, then it's going to drop out of suspension all of the material that it was carrying when it was moving fast enough to carry it. You could think about this like in football, right? If you are running with the ball and all of a sudden you get hit by somebody that's much bigger than you, who might not even have been moving before, you could potentially drop the ball because you were hit with such force that it comes loose. That's essentially the same thing as the river water carrying down that rock and soil with it as it's moving quickly. And as soon as it hits the non-moving lake or pond or ocean, a lot of that sedimentation drops out of suspension. Suspension meaning being held onto. So alluvium, right here, is a word for the rocks and soil that are moved downstream and later deposited. This occurs, again, in that process we were just talking about where water slows down. The delta is the actual location where a river meets a large body of water, and it forms a fan-shaped area of deposit. So if you've got a river that comes down like this, and then it enters into a big pond or lake, this area right here is going to be the delta, right? Because as this fast-moving water travels down here, it's going to hit the non-moving water of the lake. So it's going to very quickly drop all of the sediments right here. So oftentimes this will be a little bit more of a shallow area. You'll be able to see it from above aerially because you'll be able to see that it's a slightly different color because the sediments have risen up and have made that area more shallow. That is the area that we would call the delta. Deposition can also, meaning dropping of material, can also happen on land. So if a fast-moving river flows onto a flat plain, it's going to slow down just the same as when it hit the slow-moving water of a lake. So if this river water comes over the banks and it comes over here, or comes over the banks and it comes over here onto dry land, as it comes onto the land, it's going to drop off most of that material because it's going to be running over other dirt through grass and weeds and plants and crops and those kinds of things. This dry land area here that's right next to it, that's in the floodplain, that area is actually really good farmland because what will happen is that will flood periodically. It's going to drop off a lot of that really rich dirt, and as that dirt gets dropped off, that becomes really, really good quality soil. So that's why like the Nile River has been a great farmland on either side of the river for thousands of years because the Nile River will flood periodically, and that brings lots of really good soil onto that cropland that is next to the river. So an alluvial fan is basically just deposits of material that form up on dry land. So rather, it's essentially the same thing as a delta, but rather than being in a body of water, it's on dry land. So we can call this a dry land delta. Is one way you could describe that. Flooding and floodplains are great for farming because the periodic floods deposit alluvium rich in nutrients. But if the flood is too big, it can be disastrous. So it's good when there are small floods that come and kind of irrigate crops and drop off lots of good alluvium, meaning nutrient-rich dirt. But if the flood is huge and it moves into nearby towns and cities, it can wipe out people and cities and houses and all sorts of stuff. So obviously, a little bit of periodic flooding is okay. Too much flooding gets dangerous. So this chapter, or this section of the chapter, just kind of gives us some more insight into problems that could be associated with rivers. So for instance, we could look at flooding itself, and we could look at different rivers and different areas that flood more often than others, or more disastrously than other areas of land. It could be flooding that also happens because of storms, right? It doesn't just have to be a river that floods. It could be flooding that happened like down in New Orleans, or the flooding that happened with Storm Sandy in New Jersey and New York, right? That could be flooding that we're talking about. We could also be looking at this from the standpoint that if you build a dam up here, you're going to stop a lot of that water flow. And as you stop a lot of that water flow, all of this land isn't going to get irrigated anymore. There's also going to be less flooding for that land, so the soil is going to be of a poorer quality. Also, this lake that's down here will not be receiving as much water as it was before, so the lake will decrease in the amount of water in it, right? There will be a lot less water because the river won't be flowing as steadily as before. And if that if that lake isn't getting as much water anymore, that lake will start to become what we call turbid. Turbid means kind of cloudy and just full of dirt and non-moving, and it's not a good place for animals or plants to be living and surviving because there's not a good input of fresh water. So there's tons of different types of problems that can be associated with these streams and river deposits. So we could also go in another direction and talk about erosion and how some rivers erode too much, or how they are eroding away at riverbanks and they're encroaching on different towns and cities and could be creating problems there. So we could be talking about flooding, both good flooding and bad flooding. We could be talking about creating dams and how that affects flooding or how that affects lakes downstream. Could also be talking about erosion and those kinds of things. So we're using these different sections to give us some background knowledge, both on the science behind the problems, but also as a way that we can start to brainstorm and think about what problems might exist.